We've made a graphical model of the average rate of change tool. Today we're going to make a numerical model of the average rate of change tool, and we're going to do it using a spreadsheet. Here's what the graphical model sort of looked like. We had a point, and we wanted to find what the slope or the rate of change was between point 1 and the second point 2. So we had to move over a little bit, and in this case we'll call it H. And I think in the exercise I call it A, but it doesn't make a whole lot of difference. And then we are going to be moving up by a little bit as well. Okay, and this little bit of rise is equal to the value of the function at x plus h, subtract the value of the function at x. And so that little calculation will tell us what the rise is. And of course we know that the run is equal to h. And so if we wanted to calculate the slope, all we really have to do is calculate the rise divided by the run, which is a complicated looking formula, but it's not that hard to deal with. Now what we're going to do is we're going to make a spreadsheet that's going to do the exact same thing. And so I'm going to pick my point x. I'm just making my headings here. I said to use A, even though in this graphical analysis we're using H. We're going to calculate the function at the value of x. We are also going to calculate the value of the function at x plus h. And that reminds me, why don't I calculate the value of x plus a in a column as well? And then finally we're going to have a column where we calculate the difference function or the slope function or the slope formula. And sorry, but I think what I'll be doing is putting these ugly brackets around here. Okay, there are my headings. So I'm going to pick a value of x of 2, and I'm going to pick a value of a of 0.2. So I'm going to pick a little value of a. Now I'm going to use the formula equals a2 plus b2. So there's my spreadsheet. X plus a is 2.2. Now your function, you're going to be changing to anything you want. So let's do x squared for now. And so the cell A2 contains the value of x. So let's square A2. There we go. It's 4. And of course the function is squaring something, and so we're going to take x plus a and square it. So we're going to take the cell in C2 and we're going to square that. And now we want to take cell E2 and we want to subtract D2, and we have to do this in brackets or it won't work. So this is going to give me f at x plus a minus f at x, and I'm going to divide that by a, which is in cell B2. And this should tell me what the slope is at that point. Now what I can do, instead of using the shrinking this down graphically, what I can do now is I can just numerically change a, and I can get a really good idea of what's happening to the slope when x is 2 as I get closer and closer to that point.